Good morning. This is a quick video on my measurement systems that I use and how I do my measurements. It's not going to be a tutorial on how you use the software and bits and pieces that I use, but I get asked a hell of a lot, sometimes in the comments, but more via email. What do I use to do my measurements? How do I do it? I've had a couple of people over the last month that have actually offered to pay me to kind of do a tutorial for them as to how to use this stuff. But I'm a big believer in self-improvement, going out and learning this stuff for yourself. But anyway, that's a different topic. So my office is probably 3 meters by 4, so it's a reasonable size. I've heavily treated the ceiling. It's covered in corrugated or egg crate foam, which helps. All the little cavity spaces, say behind cupboards and things like that, are also lined with that same foam, really just to reduce any cavity resonances and that sort of thing, to make this space as dead as I can. I'll show you shortly that I gate my measurements anyway in here, but I do believe that solely relying on gating is okay, but I also think that if you can make your room as dead as you can, that you measure in, it's going to give you better results. I mean, the ultimate goal is to have an anechoic chamber, so a chamber where there is absolutely no sound reflections or anything like that. So when you're measuring a speaker, that's all you're measuring, not the room or anything. Gating is good. It is a bit artificial. Smoothing as well does negate quite a bit of the room, but yeah, I've kind of worked on this space that I use, evolved it, and measured speakers many a time outside, and then in here learnt the characteristics of this space, and you know what I can and can't trust. So yeah, it's a big process, but I do a hell of a lot of this, so I've got to get it right. So when I'm measuring, I've got a few things in the room that I know resonate. I've got a steel bin, for example, that goes outside. My beer bottles, which I've run out of, I don't keep in here anymore because they can rattle. That's no good, especially for the spectral decay and that sort of thing. But yeah, like I say, the ceiling's treated, and then what I do, I've got bulldog clips, which you probably can't see, all the way around the perimeter of the back part of my office, the measurement space. So I've got some very thick sheets that go up all the way around, and this is just quite a dead space. Like I say, I gate anyway, but yeah, it helps. I always throw a few odds and sods down on the floor. I've normally got a big sheet that I put down here as well, but just to keep it tidy. I have a tape measure which I keep in the cupboard over there, so I can always set up 1 meter. I'm going to build myself a new stand with an actual bar that comes out with the microphone at 1 meter, and a turntable on it, so it's very easy to do off-axis measurements vertically and consistently. The important thing with measurements is consistency, repeatability. It's no good if I set these speakers up, do a ton of measurements, find an issue, go off into the workshop, make some changes, bring it back, and I can't rely on the fact that I'm then measuring in almost a different space. It's got to be consistent so I can see that my changes are having a positive or negative effect. So yeah, and this kind of setup gives me that. So I use most of the time the UMic 1, which is relatively cheap. I think they're about 100 quid, 150 quid. I have a UMic 2 as well, which is a teeny bit more accurate than this, but I tend to use that if I'm really doing something critical outside. So for the most part, I just use this, and it's good. When you buy these, they come with a calibration file. I sent this off about a year ago to be calibrated, which is quite important. I'll probably be doing that again next year. But I've got a few things, known responses I fire this against, and I can sort of check it. But yeah, so I can move the microphone around in this space to do off axis. I find it's very important to move the microphone, not the speaker, because if you're moving the speaker, you're changing its interaction with the space. Whilst you're treating the space and gating and negating the room as much as you can, it's just another variable. So leave the speaker where it is. I move the microphone, not the speaker. I see a lot of people that use turntables and things like that. If I start pointing it over there at the other end of the office, which might not be as treated, then possibly something's going to be different. So I move the microphone because that's what off axis is. You're moving around the speaker with your ears. So yeah, this is my measurement tent, as I call it, and I love it. So this is the kind of egg crate that's on the ceiling. It just takes off any resonance that could be here. The lower frequencies can light up certain things in the room, so it's just good to control it. And these are the bulldog clips that go all the way around, and I can just clip up my sheets. I've only set this up just to give you an example. I've got a load of speakers behind here at the moment, which when I measure in here, I don't want all of that in here. But yeah, there we go. Right, so over at the other end of the office, there's a couple of bits of hardware I'll tell you about before I look at or show you the software that I use. So the first thing is the amplifier I use. So the software I use obviously runs on a PC. The PC has a line level audio output, which needs to run through a amplifier, which then drives the speaker that you're testing. So I've gone through a few different amplifiers. The amplifier isn't hugely important as long as it's something fairly reasonable and can drive the loads that that you're testing, and can give you the important thing is a very consistent output across the frequency range. So when you're testing at 1 watt, that it's, even though the speaker will have various different impedance swings across its frequency response, your amplifier is stable. So I've just got an old Arcam Alpha 8 which lives in here. Down the bottom there is a speaker connection point for the second set of speakers on this. So when I'm measuring, I simply switch them in, and that turns off the speakers that I have on my desk. Always on direct, so we don't use any of the bass, treble and balance controls. So we're literally audio in, amplified and out, no tone controls or anything. Volume is always at a set level, and that set level, when I've got my PC set at 90% volume, when you use a calibration resistor to set 1 watt, then yeah, it's there. The important thing is, and a lot of people I think get into trouble with this, is when you have this arrangement, you must calibrate your sound card in your PC and the amplifier you're using, because they'll have their characteristics, and you want to dial them out. So you have to, from the speaker output through a resistor, go back into the sound card on the line in and generate a calibration file. So then you know that the microphone you're using, which comes with a calibration file, and the sound card and amplifier you're using aren't introducing anything into your measurements. They're just sat there dumb, yeah, doing what you need them to do. So that's the power amplifier I use. I also use it for playing music in here, and it's all right. The other piece of hardware here is my Dayton Audio DATS system, version 3. I've had the older version 2, which is like a inline USB thing. This is the latest one. I've had this for quite a while. I don't really show impedance measurements and bits and pieces on my channel. yeah, I just don't really see the point unless there's something that really stands out. But this is a great system, and I will show you this in a minute. So that sits under here. I've got a connection point there where I plug in my measurement microphone. That goes straight back to the PC. It doesn't go through any USB switches or anything like that. That's quite important. And the same with this, directly to the PC, not through any switches or anything. Test leads for the DAT system. The version 3 comes with a 1000 ohm 1% tolerance resistor built in for calibrating it, whereas the old system you had to keep a resistor and do that from time to time. But yeah, great system. So that's the hardware I use. My crossover board is down there as well. I might show you that shortly. But yeah, in this drawer I've got all my leads and blankets and bits and pieces, loads of bits and pieces up there. So yeah, that's the hardware. So DATS is one of the systems that I use fairly regularly. I really only use it for impedance testing and kind of critical component testing, so capacitors and inductors if I really need to test something accurately. Also with the DAT system you can get all your TS parameters, so you can free air measure a speaker and then use the added mass method, add a known weight to that speaker, that driver, and get all its TS parameters that then you can use to import into software like XSIM or something like that. And then, you know, just generate a crossover based on electrical parameters, which might be 80% correct, and then you do the measuring and testing that you normally would. I don't tend to do that. I tend to just go straight to the measurement process, because it's nice to get you in the ballpark, but when you with software, but when you have done so much of this, you just get a feel for what components will get you roughly off the mark, and you tune from there. But anyway, that's me waffling on. So yeah, for example, I've plugged in this Nafiol monitor audio speaker, and if I want to know its impedance curves, I can just shoot a sweep, and this tells me quite a lot. So when you've got a ported box, you'll have a dip in the tuning frequency range. So the port on this is tuned to about 80 hertz, and you can also kind of electrically see where the crossover point roughly is. So as our impedance is rising here, we can see that the woofer is rolling off electrically, and then the resistance is decreasing again, which is where our tweeter is rolling in. So based on electrical measurements, the crossover point for that speaker is around 1600 hertz, which is nice and low. When you shoot your actual acoustic measurements, because of the baffle and various other things, yeah, that might not be entirely the case. Also, this tells you if you have any cabinet resonances and things like that. You'll see these wiggly lines here, and that's quite telltale of an internal resonance. I mean, this is a plastic box, so I'm not too surprised really. So yeah, that's the impedance side of it really. Okay, so I use DATs, as I mentioned, for component testing. So I've got a 25 microfarad Solon polypropylene capacitor here, so let's measure that. And this gives me the exact value, 25.45 microfarad. But then it gives me a range of measurements at different test frequencies, which is really handy. So the ESR value, which is nice and low. It gives us the dissipation factor. And all these measurements are quite useful, especially for comparing capacitors. So that's a polypropylene cap. So what I'm going to do now is put in a 25 microfarad electrolytic. And straight away, very different readings. So for starters, we're just over 28 microfarad. Our ESR value is very, very different. So is the dissipation factor, blah, 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 blah. And that's, as I mentioned a number of times, one of the reasons why you can't blindly swap these for these without adjusting the value. Because it just doesn't work. The speaker needs to be voiced, measured, and designed with the components you intend to use. So yeah, it's just useful for the background stuff that I do. Like I say, I don't really use it on my channel. It's just, yeah, a good system. So I guess the most important piece of software I use, and I feature it on my channel quite a lot, is REW, Room Equalization Wizard. You can use it for room EQing and things like that, funnily enough, but I just use it for speaker measurements, and it's really good for that. Like I touched on at the beginning of the video, you have to spend the time setting this up. If you think you're just going to get yourself a measurement microphone, REW, and all of a sudden you're a master speaker designer, yeah, it sort of doesn't work like that, unfortunately. It takes a lot of setting up. The thing that really hit me initially when I started using this many years ago was to trust it, learn to trust it, and to also have a method of checking it too, which was, yeah, took a few it took a lot to get that, but yeah, I do trust it now, and it's a great piece of software when it's set up correctly. I mentioned in one of my other videos recently that I was looking at purchasing Clio, which is a really good system. The main benefit to that, to me, is the hardware it comes with. Because REW needs, you know, a power amplifier, a sound card, blah blah blah. With Clio, you can buy the box of tricks that's got everything in it. It will do everything that DATS does, which I've just shown you, everything that this does, and it's yeah, a very bulletproof system, and yeah, really what the professionals use. But REW is great. Arta is another good piece of software. I've only dabbled with that. I keep coming back to this, so so I like it. So this gives me pretty much everything that I could really want combined with DAT. So I can get my on-axis measurements. What have I got switched on here? I don't want to. My on-axis measurements, my vertical measurements, obviously my horizontal measurements, blah blah blah. I can also look at the phase relationship for the speaker, which is something we're quite sensitive to. That can often tell me where the crossover point is, and blah blah blah. It's very good. I can look at if I've got issues with the sound of a speaker. Clients reported something's not sounding right, rattling, buzzing, humming. I can look at the distortion and see if there's anything cropping up above the noise floor. I can also look at the spectral decay. This actually takes quite a bit of setting up. It's not out of the box. So the time domain you're measuring in, rise time, the amount of slices you have, how it's smoothed, it can take quite a bit. And then of course you will gate as well, so you'll add your details in here based on the impulse response. So you'll look at the timeline and where you're seeing room reflections creeping in and dial those out. So it takes a bit of learning and a bit of setting up, but it's once you've got it right and learnt it, it's great. But like I say, it takes a long time to get your head around these things. Yeah, so that's the stuff I use to do all my measurements. I did a video a while ago on the stuff I use in the workshop, my little atlas tester for components and things like that. But when it comes to measurements, this is what I use. I think it's really important that the measurements, you understand that the measurements are a tool, and it takes a lot of learning, and it's taken me a long time to get my head fully around all of this. You know, I've been doing this for a long time. It is my job, or part of my job. Probably the majority of my job these days. I'm also an electrical engineer, so I'm sat in here doing a lot of electrical design work, CAD work, that sort of thing. But speakers have become, in the last 5 years or so, quite a big thing. So for me, hence why I'm now at the point where I'm trying to design my own little line. But yeah, it's important to understand that these measurement systems are a tool, and no matter how flat you might get your response, I don't think that's the be all and end all. These are the be all and end all, and my personal opinion is I don't think any of these measurement systems mean anything if you don't know what you should be listening for and what you should be listening to, what's right and what's not. A lot of that is personal taste. This is why we have so many speaker manufacturers out there with their own voicing, you know, their own take on speaker design. If the goal was just this flat response, which for a lot of people it is, and that's it, I don't know. A speaker shouldn't add coloration or anything to the sound. A speaker should faithfully reproduce the music, but we like listening to music in a certain way. I know I do. I prefer a response which has a kind of 1 to 4K dip. A lot of people don't. That's kind of makes the speaker a bit more laid back. The detail and clarity and everything's there, but to me that gives you a bit more body down the bottom. I suppose it's a similar sort of thing to what your loudness switch used to do back in the day. It tilted up the top and the bottom, dipped out the middle. But that's personal preference. You've got to have your own style, your own taste. And yeah, like I say, picking up this equipment and thinking you're just going to design something, it's going to be great based on all these graphs, I think is wrong. But that's my personal view. I've always been into music, loved listening to music. Far back as I can remember, hi-fi has always been a big thing. Building speakers has always been a big thing. And off the back of that, understanding what sounds right, what doesn't. Again, going back to these systems being a tool, when you do your speaker design and you listen and you hear something's not right, you soon learn to then go back to your measurements and see where that's right and wrong, find that issue, and then it helps you correct it. But they are tools. But yeah, there you go. I'm rambling on now. I'm going to shut up and yeah. Have a good weekend, everyone, because it's Friday.